Okay, today we are starting Unit 3, and Unit 3 is all about different ways to solve. Specifically, today we're looking at solving quadratic equations using the zero product property and by completing the square. We've used the completing the square before for equivalence, so that means that we're rewriting an equation in equivalent forms. So different forms that are the same graph, same table. And we've had three so far. We've had standard form, we've had factored form, and we've had graphing form of a quadratic specifically. But really you could rewrite any equation or expression into a different form to show equivalence. Solving, on the other hand, is where we take an equation and we solve for an actual variable. Most of the time, specifically for our quadratic equations that we've been working with, we're looking at x and y. However, there could be other equations that may be a little bit more complicated that does not involve solving for x and y. We can solve for any variable, really, using a variety of techniques. So that's what we're looking at in Unit 3, is we're going to look at different ways that we can solve expressions and equations, and different ways that we can rate equivalent forms of these. So a couple, some terminology I want to look at is roots and zeros. So the roots or zeros of a quadratic expression are the values of x that make the value of the quadratic equal to 0. Well, if it's equal to 0, then that must mean that it is an x-intercept if y is equal to 0. So really what we're looking at is if we have an equation and we want to solve that equation for x, then we're finding actually the x-intercepts of that equation. And we've had, as far as solving, there's a few ways that we can solve this quadratic equation. We can go through and we can graph and locate the x-intercepts. And remember, now we're saying that x-intercept is the same thing as a root or a 0. Those are just all words for the same thing. So we can graph and find the x-intercepts. We can use the quadratic formula. And remember, the quadratic formula was that x equals negative b plus or minus square root b squared minus 4ac all over 2a. So that was our quadratic formula. Typically, we would take standard form, so a, b, and c, and put that into the quadratic formula, and that would give us our x-intercepts, so our roots or our zeros. We have before factored to get our quadratic equation in a different form, but have not had as much solving. We're going to look at today factoring and using what's called the zero product property to find the solutions, to find the zeros. So that's new for us. And then the other thing is we've completed the square to put the equation in a different form, to put it in graphing form. But we have not used it to solve yet, and we'll be able to use completing the square to put it in graphing form and then to go through and solve for x. So let's start with our new concept of the zero product property, which you may have seen before. So zero product property goes like this. It says that if you have things being multiplied, so let's say if I have a times b, and that's equal to 0, then one of these two numbers, a or b, has to be 0 to get equal to 0. You can't multiply and get 0 without at least one of them being 0. So A has to be 0, or B has to be 0, or it could be that both are equal to 0. But we know that when we have things multiplied, so it doesn't matter how many things I have multiplied, if I only have multiplication and it's equal to 0, at least one of those things has to be equal to 0 itself. And we don't know which. So really what the zero product property says is pretend like each one of the factors, each one of the things being multiplied could be equal to 0. And we're going to be setting up kind of like mini equations to go through and solve. So let's see how this is done. The first thing is for zero product property, to find the roots. So remember that means x-intercepts or zeros, those are all the same thing. We have to have factored form because zero product property is assuming we have a product, and another word for product is factored. So it has to be factored first before we can actually use the zero product property. So let's take for A, we're going to go ahead and factor. So I have my box, and I'm going to take first term, first box, so 3x squared. Last term, last box is 4. And our middle term, negative 7x, I need to break up to get to these two middle diagonal boxes. They should add together to get negative 7x. So 3x squared can be broken into 3x times x. 4 can be broken into 1 times 4. So we have 3x squared, 4x, and 3x, but I want to make a negative 7x. So I'm going to stick a negative on the 1 and the 4. So this turns into being 3x minus 4 times x minus 1. We're going to put that equal to 0 because we want to find the value of x. So we're going to solve, which means we have to have an equation. So this is where we can use zero product property because I have two things that are being multiplied. I have this 3x minus 4 and I have the x minus 1, and they're being multiplied to get 0. So that means one of these, at least one of them, has to be 0, but we don't know which. So it's like saying, okay, this first group, 3x minus 4, is equal to 0, and x minus 1 is equal to 0, because we don't know which, so we just assume both. So now that we have two of our mini equations set up, we can go ahead and go through and solve. So I'm going to undo by adding the 4, and I'm going to undo by dividing 3. So I have one x-intercepts as being, one of the x-intercepts is 4/3 for x, and then the other one is 1. So if we want to check our answer, we know that since these are x-intercepts, y must be 0. So if we put in 4/3 everywhere we see the x into the original problem, it should give us out 0. Same thing if I put in 1. So if I put in 1 for each one, it should give me 0 back out if I did it correctly. So the next problem, let me clear this off. Okay. So let's look at B. We have to, once again, to be able to use the zero product property, have it in factored form. So very first step of factoring that's easy for people to forget is the greatest common factor. So this x squared plus 6x, I'm going to set that equal to 0. These both have an x in common, so I can divide out that x. And it does not disappear, it just sits on the outside, because really I'm doing equivalent forms here. They should, if I distribute that x back in, it should get back to the original problem. So once again, now I have a factored form, and I can assume that each one of these parts is equal to 0. So I have x equals 0, which already gives me my answer. And then I have x plus 6 equals 0. And if I solve that, then x is equal to negative 6. So we have two answers of 0 and negative 6 for that one, for B. And then the last one for C, C is already in factored form. So I can set this in equal to 0, and I'm going to have two mini equations for this because I have two things being multiplied. I have x plus 5 is equal to 0, and I have negative 2x plus 3 equals 0. So for x plus 5 equals 0, I'm going to subtract 5 from both sides, and we get x equals negative 5. And then the second one, I'm going to subtract the 3. So I have negative 2x equals negative 3. And when I divide by negative 2 to undo, I have x is equal to negative 3 over negative 2, which would be positive 3 over 2. So there's my two x-intercepts, which are my roots, which are my x values. Okay, so if an equation is not factorable, what do? Does that mean that there's no solution, there's no x-intercepts? Well, we have to remember that our x-intercepts can be things other than whole numbers. So for the example of this graph here, I've got two x-intercepts that are decimals. But when you factor, you're factoring only with whole numbers. It is way too difficult, and we don't ever factor with decimal numbers. So if you cannot use whole numbers to factor, we consider it not factorable. So that does not mean that there's no x-intercepts or zeros. That just means that they may be decimals. So what we need to do then is use a different method to solve the equation to find those x-intercepts besides factoring and using the zero product property. We already know way back that we can use the quadratic formula for any quadratic equation and find the x-intercepts. So as long as it's in standard form, so this one is in standard form because remember standard form is ax squared plus bx plus c. As long as I have an a, b, and c that I can plug into the quadratic formula, then I can go through and find my x-intercepts if there are any. But another method we can do is to complete the square. We've completed the square before to make equivalent forms, to change standard form into graphing form. That's why we usually complete the square. So we take standard form and change it to graphing form. So that way we can go and graph it. But in this case, our focus for Unit 3 is about solving. So if I have something in standard form, we can use completing the square to solve by putting it into graphing form first and then undoing and solving algebraically. So when we go to complete the square, let's take a good review of completing the square. X squared minus 6x plus 1 equals 0. And we need to remember how to complete the square. So completing the square involved the first two terms, and we wanted to make this into graphing form. And remember, graphing form was where we had a times x minus h squared plus k. But in this case, for all our completing the squares, our a value was 1. So really, I want something squared plus k is what we're trying to get to when we complete the square. So to do that, I'm going to focus on the first two terms, the x squared minus 6x. And I want to add something squared. And then, so I didn't really change the equation. I also need to subtract that exact same thing off. So minus something squared. That way, that plus something squared minus something squared is going to be 0, so I didn't really change the equation. The thing that goes inside the box is this middle term, so negative 6, and we're going to divide it by 2. So I have negative 3 and negative 3 that go into the box for that. So when I do that, this x squared minus 6x, this is plus 9. If I did the box and factored that, it turns out to be x minus 3 times x minus 3, or x minus 3 squared. And really, if you notice that the negative 3 inside the box comes out to be what goes inside the something squared. Then I have the rest of the equation, so plus 1 minus negative 3 times negative 3 is 9 is equal to 0. So we have x minus 3 squared minus 8 equals 0. So we're used to doing this, and this is in graphing form now, and we would take this and find the vertex and graph. However, our goal is not to graph it. Our goal is to find and solve to find the zeros, or also called the roots, also called the x-intercepts. So we're really just solving for x is our goal here. So this is where our algebra is going to come into play. And I'm going to undo things. And remember, forward would be PEMDAS. Please excuse my ignorant Sally. But undoing, unwrapping would be SADMAP. So I'm going to undo subtraction addition first. Okay, so let's write that over here. So I'm going to add the 8 to both sides. Okay, no more subtraction addition. I'm going to undo division multiplication. There is none. If there was, it would be out here in front to the left. And then I'm going to undo the exponent. So to get rid of the square, we need a square root, both sides. And remember that that square root can be positive or it can be negative. And that is what gets rid of the square. They're opposites. They undo each other. So I have the x minus 3 equals a positive and a square root of 8. Positive and negative square root of 8. So really, this is saying I have x minus 3 is equal to just a positive square root of 8, and x minus 3 is equal to negative square root of 8. So then I need to just add 3 to solve, because I have too many equations going on here. So I'm going to add 3. And I have x is equal to 0.17 about. And I'm going to add 3 on the second equation. So negative 8, square root of 8 plus 3 would be the 5.83. So that gives us our 2 x-intercepts. Once again, if we plug those back into the original equation, we should get 0 back out, because y is 0 for x-intercepts. So let's try a few more of these, so that way we make sure we understand what's going on. There's really 2 things that are going on. We have to be able to complete the square first, and then we have to be able to go through and correctly solve it. So completing the square and solving, I want to make sure that this is equal to 0, so I'm going to add the 2 over. And I have x squared plus 4x minus 3 is equal to 0. And now we're going to complete the square. So that means I'm going to focus on these first 2 terms. And I'm going to have, so x squared plus 4x, I'm going to add something squared. And then I'm going to subtract off that something squared again. The thing that goes inside the box is this middle term divided by 2. So I'm going to put a 2 inside the box. When I complete the square, then I have x plus, and then that 2 is going to be my inside of my square. Minus 3 minus 4, so minus 3 minus 4 would be negative 7 is equal to 0. So we just need to go through and solve. So I'm going to add 7 to both sides. So I would be done if I was just completing the square, but now we're actually at the solving part. So I'm going to add 7 to both sides. It's equal to 7. I'm going to get rid of the square, so I'm going to plus and minus square root both sides, which gets rid of the square. So I have x plus 2 equals positive and negative square root of 7. And then I'm going to subtract the 2. So I have x is equal to, I need to do positive square root of 7 minus 2, and negative square root of 7 minus 2. So really I should have 2 answers here. I have 0.65 and I have negative 4.65. because I have to do two equations here. I have to do x equals positive square root of 7 and then subtract 2. And then I have to do x equals negative square root of 7 minus 2. So that's why I get two answers down here. These are my two roots, my two zeros, also known as x-intercepts for that one. And if I put them back in, I should get 0. If I graph this, those will be my two x-intercepts. So there's many ways that you can and should be checking your answers. So the last one, let's go ahead and try this again. You guys should be trying this along too to make sure you understand this. Once again, I need to get this equal to 0 first, because we are assuming that this is equal to 0, because y would be 0, which would give us our x-intercepts. So x squared minus 2x minus 4 equals 0. I'm going to complete the square and solve. So I'm going to take x squared minus 2x, and I need to add something squared and then subtract something squared. So I'm taking the middle term, which is this negative 2, and I'm dividing it by 2, which gives me negative 1. That helps us complete the square. That negative 1 is what's going inside the something squared. And then I have minus 4 minus negative 1 squared. Well, negative 1 squared, so negative 1 times negative 1 is positive 1. So I have negative 4 minus 1, which would be negative 5. So this is negative 5 equals 0. So that's the completing the square part. Now we need to go through and solve. So to solve, I'm going to go ahead and add the 5 over. So I have x minus 1 squared equals 5. I need to get rid of the square, so I can take the positive and the negative square root of both sides. And I get x minus 1 equals positive and negative square root of 5. Really, this is having two equations. So I have x minus 1 is equal to positive square root of 5, and x minus 1 is equal to negative square root of 5. So if I add the 1 over, I get x is equal to 3.24, and then for our second, our negative square root of 5, I get x is equal to negative 1.24 for our x-intercepts. Okay, so that is completing the square and solving, and also we looked at zero product property and solving with that from factored form.